So let's hit it off. Our basic presentation on this, and we'll start with a few entry remarks on this. First of all, the key messages that we have when it comes to cloud and cloud FinOps, financial optimization in the cloud, is that cloud cost optimization is far more complex than you're used to. So basically what's happened is when you move to the cloud, managing cost becomes a discipline that is completely different to managing cost when you ran things in your own data center or when you outsourced your IT operation. It's a lot more complicated, and we'll show you a lot of those complications in a short while. If you don't continuously optimize, so not only is it complicated, but you need to do it all the time, because it will get out of hand if you don't do anything, if you don't optimize as you move along. You need to understand both your current but also your future capacity need, because your optimization will need to take into account where you expect your capacity to move. And Morten will show you some examples where, for example, reserving capacity to lower your price can be a bad idea, because you'll then basically lock up your capacity at a specific level and at a specific technology for 3 years or 1 year, which might not be what you really need when you look ahead.
Yeah, there's different levers that you can utilize to get these cost savings, and that we go through during this presentation.
You need to be able to change resources as you move along, because that's one of the ways you'll achieve the savings that are necessary here. But you need to calculate the cost of actually doing that change, because that's of course part of the business case. And FinOps that we're going to talk about today is a new central discipline for organizations. And we see most of our clients having a huge focus on just building up FinOps capacities and competences in their organization. Okay, what we'll see in what we have seen in the present years and what we will see in the years to come is a significant move of workload from on-prem and classical outsourcing to cloud. Our big market report showed that during 2022, a lot of workload was actually moved to the cloud, not as much as anticipated, but a lot of workload was still moved to the cloud, and more will be moved. There are, of course, a number of inhibitors, such as compliance, worries about compliance and other things, but still we're seeing a lot of load being moved. And most organizations, as we state here, will end up in a hybrid setup with a combination of on-prem or outsourced on the one hand, and then cloud on the other. The move to the cloud will mean that the marginal cost of on-prem capacity can increase, because basically you're moving capacity out of your own data center to the cloud, but you still have a lot of the basic cost in your data center. So you run the risk of actually increasing the total cost. Recoding application has proven much more difficult for many organizations than they thought it would be. So that is one of the reasons why we see that the move to the cloud is not as expedient as most organizations perhaps thought it would be. Yeah, we are repeating ourselves by saying that FinOps is becoming an important discipline. We cannot state that enough. And the organization must keep up with the use of the cloud. They need to monitor the use of the cloud and the cost there continuously. And in order to make cloud work, you need to have your cloud management in place. And cloud management is not only about FinOps, of course. Cloud management is primarily about the operational tasks that you need to handle. It's about governance, it's about architecture, and then it is about FinOps, and FinOps is what we're moving towards. And this, Morten,
this is what we came for.
This is what we came for, because basically the challenge was, can we beat the Azure Analyzer? Advisor.
Advisor.
Yeah. So take us through here, Morten.
Yeah, I can take it. These expense is from a peer, where we have the 100 the index 100 is what they paid in a given month. And then based on the Azure Advisor, they can lower their expense by 35%, which is the darkest blue. And then based on our analyze using different levelers, we will go through this presentation, we can get optimization on the virtual machines for 42%. And we also take a deep dive on the SQL instance resources at Azure. The advisor can lower the expense with 16%. And we found levelers that we can lower it with 32%. So by that, I would say that I have fulfilled the task and beaten the Azure Advisor cost optimization.
Which is good. So that's good. We just had the employee development talk before you did this. So you will get the full benefit next time. But the interesting thing, I think, is not only can we demonstrate to you what you can do in order to basically beat that tool, but as we will show later, using the Azure Advisor, and we're not saying you shouldn't use the Azure Advisor, but using the Azure Advisor will typically give you advisors that will also entail a larger commitment and upfront payment.
It's heavily focused on CapEx in this case.
So basically what we'll show you is that yes, you can get to 65 using what is the advisors you get from Azure Advisor, but they will include a lot of reserved instances and others where you actually have to pay up front for a lot of capacity, and you have to lock a lot of capacity. So this is the dilemma that you will find yourself in. Of course, working at the index 100 would be crazy, because why would you spend 100 if you can go down to 65 or 58 for the virtual machines? So just doing nothing is crazy. But now the question is, what should you do?
Well, that get back to the topic of FinOps.
Exactly. So, okay. So I think we'll skip this. So first of all, I think the first thing you did was to take a look at the consumption. What does it actually contain of?
Yeah, well, it varies from peers to peers, of client to client, to what resources or technology they focus in using in the cloud. But this particular customer has a heavy utilization of SQL databases, virtual machines, and log analytics, and then the Azure App Service. So that is like the top 4 of the resources they utilize in the cloud. And actually, the top 5 resources make 2/3 of the spend in the public cloud. So when you're looking at cost optimization, you definitely start looking at the biggest expenses.
Obviously.
Yeah, and then you have a big group called others. What is other? That is everything else in the cloud. It's firewalls. It may be machine learning. It can be IoT. It could be everything else. But it's just to aggregate, otherwise we'll have a very long slide.
So the first thing you do is, of course, to look at the different resources. Some of them we have good tools to optimize, others are more difficult to optimize. But luckily here, the SQL and the virtual machines are things where we can actually do something.
Definitely, because the task with the SQL databases and the virtual machine is, it's just like the typical on-premise hosting. So when people move to the cloud, they take the architecture and the processes they had on-premise and move it to the cloud. But the cloud is more focused on scalability. So you need to use these on-demand scalabilities levelers to utilize the cloud better and get a better business case.
Okay, I'll try something new here today, Morten. So basically we'll go in full scale here. So this is, what is it we're looking at here?
Well, we have the x-axis down here that we have spent over time, and then we have economy up at the y-axis, and we can see at some point a peer have implemented a new functionality, and we see a spike in expense. It might be, was they utilizing a resource wrongly? Had they set a wrong, like when you put a virtual machine up, was it too big and they need to downscale it? And it keeps going on. Like every time you implement something new, you get a spike of cost. Can you anticipate these costs? It's hard to answer that questions, but you definitely need to monitor the cloud, because this spend might never have come back down if you haven't doing FinOps. So you need to monitor your expense and your cloud utilization.
So basically, the idea is you need to look at the meters all the time, because things can happen when you implement new stuff, and you need to take care of that. And sometimes it's the programmers or the people implementing the systems that needs to basically look, can we do something? Was this because we did something wrong?
Was it too big a machine? Was the resources correctly allocated? You need to monitor the cloud, because otherwise it can spin out of control if you don't have an eye on your expenses in the cloud.
So you would say conclusion number one is make sure you have people that looks on the dials, that monitor the consumption as you go along and compare it to what you expected it to be. Now, we need to look at the optimization levers, what you can do in order to optimize. And basically, we are looking at least 7 different levers here. And I'll just go through them very briefly, and then we'll go into details. One of them is rightsizing based on actual utilization. We'll spend a lot of time on that.
Definitely.
So selecting the right servers, selecting the right SQL resources that actually is the best fit for your actual utilization. Then you need to decide whether your capacity should be in the cloud at all, or whether you should take it back. There will be a long discussion, we believe, with many of the vendors that can provide both classical outsourcing and cloud management on when it is the right thing to do to take capacity and basically moving it back to a traditional data center. Because in many cases, you might even be able to negotiate a better price with your vendor if you're looking at the alternative of either the cloud or the on-prem data center with your vendor. Then the big kahuna here, the reserved instances.
Of course, we're going to cover that topic.
The Azure, the Microsoft way of giving you a cheaper resource in exchange for basically locking it up for 1 year or 3 years. And then basically the alternative, trying to optimize yourself as you move along. So that is making sure you have the right combination of resources at all times. Then we're looking into storage.
Yeah, storage lifecycle management. Typically not something you would do on an on-premise setup. You will have all your storage in a SAN, and then you will have a backup. But the key challenge in the cloud is that you need to monitor your storage. Is it old? Is it getting older? Then move it accordingly to like cheaper consumption-based pricing. And that's also a topic we'll be covering in this presentation.
But there's a snake in this garden, and that is that cold storage is cheaper, but can be a lot more expensive if you use it wrong.
Don't set the wrong flag at some point when you create the storage account. That is the topic.
And we will, those of you who stay all the way through, and we believe all of you will get also the story and the tips and tricks on how to make sure that you have the right mix of hot, cold, and archive, which is not self-evident. And then there's the question of where do you put which region do you choose? And last, there's software license optimization.
Yeah.
Do you bring your own licenses, or do you rent your licenses together with the capacity that you buy? And the last choice can be quite expensive. Okay, so we'll start off with one of the things that we believe almost all of you will have to look into. That is the optimization of the virtual machines.
Yeah, it's definitely the on-premise going cloud.
I know that many of you have been to presentations here before, so a lot of you will know our cloud archetypes that we publish once a quarter in quarterly analytics. I will just go through them briefly. The cloud archetypes are 5 different application landscapes where we've collected information about consumptions with the clients where they reside. And then we've basically taken the capacity pattern and put it into our benchmarking model. So we know, so we give you the black bar, that is the price you should expect in a classic on-prem setup. So that would be the total price of providing that application operation on a monthly basis. And then you have the 3 colored bars. That is when we translate the consumption pattern into the best fit in Azure, AWS, and Google, but with no optimization at all.
Nothing.
No optimization at all. So we just do a one-to-one move of the capacity. And what this graph shows, I'll just remove us for a while. What this graph shows is basically that if you're on a Windows operating system in this quarter, because this changes over the time, but if you're looking at this quarter, well, basically it shows that it will in almost all cases become more expensive to move to the cloud in a one-to-one move. It's a little different if we are on the Linux operating system, but it's still the overall pattern is still the same. There's no real saving except for a few cases in moving things to the cloud one-to-one. So you need to optimize. So FinOps is key when you move stuff to the cloud, because otherwise your cost will spiral out of control and it will basically become more expensive than you're used to.
I just have one thing to point out, and maybe not, it's just always cloud, it should be cloud right. So you need to analyze your application, are they fitted for cloud? Because otherwise they will be better at the on-premise settings. But that is of course up to the individual client to determine which business are cloud ready. And then it's always like the term cloud right.
Exactly. So and what you will find is that there's a lot of more complications here. If you move one application to the cloud, you might have to move a whole family of applications because they are talking to each other and you'll get latency problems and so on. So moving to the cloud is not a simple task.
And then you have a string of long applications that have legacy dependencies, and that is an issue because the cloud is always live and up to date. So you need to have virtual machine at given versions, and that can also drive up the expense.
So over the time, for example, Microsoft will issue new versions of their servers. So the way you get more capacity and you get lower prices is basically by utilizing the newer versions. And then let's go into the optimization.
To the challenge.
To the challenge. So tell us, Morten, what did you do in order to meet the challenge? And I think perhaps we should step a little back here.
Well, the first thing I had to do was that I started getting the metric of every virtual machine. When I say the metric, what is that? That is the CPU utilization and the memory utilization. So here I have a whole month of CPU utilization, and I can see that there's some spikes here during the days. And I can tell you that this is Monday, Tuesday, and then it goes down dormant. Then we have Monday, Tuesday, Wednesday, Thursday. So you can see that this application actually mostly is utilized during the weekdays. And then I can see down here that the memory utilization is actually quite high, so it has a lot of memory. So this is definitely, we have 4 cases. This is the case number 1, a candidate for newer version. Why would I choose a newer version for one that has such a high utilization? Well, it all comes down to the current has 4 CPU, 28 gigabyte of RAM, but if I move it from a version 2 to a version 5, I get the same vCPU, but a bit more of memory. Why should I do that? Well, actually, it reduces cost with 4%. Then, of course, there's this internal evaluation. The man hours it takes to move the application. Is it worth it? Well, it's up to each virtual machine. So that is the case number one. A newer version will give higher CPU performance and a bit more memory.
So this is an example. Yeah. So this is basically an example where you'll get a smaller saving, but you'll get a newer machine, and perhaps this machine, because we don't know whether this machine will actually perform so much better that you could basically do with a little fewer.
I don't believe it, because then you have to cut the CPU in half, because the next one is two CPU.
That's not really the case here, because but in some cases, if you take a look at a picture like this, and you can see, well, basically I can get more memory for a little less price. In some cases, it is relevant also to consider whether you basically can utilize the fact that newer versions will have more
better performance.
So basically, they can produce more transactions per minute. In this case, it might not be. In the previous case, it might not be the case. But in some cases, when you have, for example, an application running on, say, 10 vCPUs, it might be relevant to say that, okay, version 4 here has a performance count of 653. That's the left blue bar in the red box. And you can see that if you scale that up to the newer version, the version 5, you can see you get to a performance count of 790, I think it is.
Yeah, it's 790.
790 in the performance count, which basically says that it can compute more calculations per minute than the older version. And therefore, if you had, say, 10 VMs in total, you might be able to do the same job with 9 or 8.
Definitely, that's also an optimization that you need to always keep track of your cloud utilization and how you use it, and then also bring us back to reserved instance. Because if you reserve the instance, then you wouldn't be able to do this version gain because you have locked the instance in a capex, so you would be stuck on this machine during the reserved instance period.
Now, looking at the performance, which is what we do on this graph, it is fairly new in the sense that Microsoft does not publish any performance counts on the VMs.
No, very vaguely.
Only very vaguely. This is from a source that we just stumbled upon that's called Cockroach Labs. It's really a company that manufactures a database, and they run performance benchmarks on different versions of the most widely used VMs on both AWS, Azure, and Google, in order to basically calculate how much juice do you get out of the different VMs. So it's much like MIPS counting in the old in the mainframe area. So yeah, let's skip that. So what we are seeing is new versions tend to be a little cheaper than the older version.
Yeah.
Not significantly cheaper, but they're a little cheaper. They give you higher performance, so you get more transactions per minute out of the servers. In order to utilize that, you basically need to have a setup where you can scale down a cluster of VMs to a smaller cluster, because otherwise, by just taking an application running on one VM and moving to the newer version of that VM will not, of course, give you the full benefit of the performance increase. It will only give you the price decrease. Yeah. But as Morten showed before, you could switch to another CPU, to another VM, where the combination of CPUs to RAM is more optimal.
Yeah, but the ratio is more optimal to the given utilization. But then you need to do analysis of your current VMs to know which are candidates. So every time we look at a VM in this case, we flagged candidates. So is this candidate for new series? Is it case 2, 3, or 4 that we go to just in? Yeah, we're getting to it now actually.
I think there's one thing worth noticing here is that this first case is a case where the peaks go to almost to 100, right?
Yeah.
So it's not like this has not been wrongly in terms of total capacity and so on. There's not an underutilization issue here.
No, I would definitely say it's a well utilized machine. The only, if we can derail just for a short bit, maybe this application would be benefits of getting of something more scalable, because clearly it's only utilized during the weekdays and not the weekends based on the peaks. So there might actually be a transition. Yeah, so just going
that's
back
basically
to
saying
Monday,
that,
Tuesday, Wednesday, Thursday. So we can see definitely only the weekdays. And same goes here. It's never really utilized during Saturday and Sunday.
And the interesting thing here is, of course, what goes on Sunday and Saturday and Sunday. Is it completely unused? So is this?
No, it's not unused because it's under 50% utilization. But that would be a question for the client. What does the application do? Is it just dormant? What kind of calculation is it doing? Is it doing some batch jobs? We do not know, but that is always like the next case for the FinOps to do this, analyze what it does.
Yeah. So we'll get back to that, of course. Yes. So okay. So another example.
Yeah. This one is, like I mentioned before, a candidate, case 2, candidate for rightsizing. So it has a CPU utilization a lot lower, so it doesn't do that many applications. But we can still identify some peaks around here. There's a group of peaks here, 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 and here. And we can see there's some really high calculations up here. So,
but Morten, just a question. So there's a few dots. There's one here, for example.
Yes.
But this is close to 100. This is 90 something.
Yeah.
But it's the only one really.
One more.
There's one. Okay, difficult to see. So there's a very few peaks that gets you almost to max capacity.
Yes.
But the average is extremely low.
Yeah. So what I would do in this case is that we're going to also see the memory. That is, it doesn't really have a pattern, only out here at the end where it has a small peak. So some memory or calculation is actually been doing here as the memory is being more utilized. So my recommendation for this machine is that we have a 4 CPU, but I would scale it to a 2 CPU and keep the memory stationary. Well, if I scale it to a 2 CPU, I would actually cut everything in half over here. So all the dots above the 50% will be cut. What does that mean for the application? Well, it actually only means that the calculation, instead of 1 second, it might take 2 seconds. So when you're at 100% memory or CPU utilization, it doesn't mean that the calculations never get done. It's just get queued in the calculation queue in the CPU. So it's not because it's getting dropped. And just one more point. We are at version 3, and scaling to a version 5, also given Moore's law, give you better capacity. So it might be even fewer dots that get cut by scaling the machine down.
So obviously, if you want to do this, the expectation should be you'll have you can see the dots above the 50 mark here. You should expect a little longer response time on whatever you're doing there.
Yeah.
And of course you have to ask yourself, what is this application doing? Is this people waiting for a response to a database query, something like that? Probably acceptable. Is this a automation system running on the factory floor, controlling robots in real time? Then it might not be such a good idea.
I got a small keynote actually. It's a development system. So back to that, can the developer maybe get another cup of coffee before the calculation is done? So we definitely have some saving, but we actually forgot to mention the price. the difference is 41% just scaling the machine down. So that actually is a big saving quite fast. And that is per hour you get these savings.
So basically what we're saying here is you should be looking for these kind of patterns. This is a pattern screaming downscaling, making sure you select the right combination of VMs, of CPU to RAMs, to actually fit the consumption pattern. And there will be lots of these.
Yeah.
I mean, when we go out and look at in FinOps or stuff, when we look at the utilization, we find a lot of these servers, even more extreme examples than these, and we'll get to some of them, but we'll see a lot of these examples out there of underutilized servers. Why is that? Well, probably some of these are the result of moving from a VM in an on-prem or outsourced setup to the cloud, where you did the one-to-one.
Yeah, the shift and lift, actually. You just took the same capacity up in the cloud.
Yeah. And when you had it on-prem, you probably, back then in the days where you commissioned the infrastructure to the application, you probably took a good guess. I think this will run well with a 4 CPU, 16 gigabytes of RAM. You put the application in your data center, and hey, it worked. If it ain't broke, don't fix it. So no one really went back and said, could we actually do with less? But in the cloud, you pay for every single piece of
every calculation, even the dormant that actually just do no really work.
Yeah. So basically, it's a really bad idea in the cloud to have these underutilized servers. So you need to right size. You need to pay attention to these kind of examples. Okay. So here's another one.
Yeah, that's another one. That's a case-free, a candidate with intensive utilization for a short burst of time. So we can see it's still a whole month of data points. And then we have an extreme spike here. It looks like a Wednesday spike. And then we have an extreme spike on Monday. So my recommendation would be to utilize the burst machine instead. So we go from 4 CPU to 2 CPUs. And memory, we also scale down from the 16 to the 18. I'm fairly sure that I will be able to scale it down given it's a burst machine. We have a small peak here. But the idea behind the burst machine is that for small amount of time, you can utilize additional capacity. Thereby, the burst machine could handle this small burst in memory. So when your burst machine doesn't overutilize, it takes a cap. If you have 100% and only utilized 50%, then this last 50% is credit for your coming bursts. So all this time it accumulates credit, and then it gets a burst and use the credit to do this burst calculation. And then it goes down again and accumulate new credits for your next coming burst. And that would make a savings of 75% per hour.
And I feel almost like the TV shop. So are you really saying here that
we need some grayscaling when it's dark and then what the solution is?
So you can really so now we are getting to some real numbers here. Basically saying this is an underutilized machine. It's even more underutilized than the one before, and the characteristic is it only bursts at a very few instances.
Yeah.
So this is a candidate for the so-called burst machines. Now the question is, will Microsoft suggest you to move to a burst machine?
Not always, actually. It varies. Microsoft did advise some of the computers moving to a new series. We did a black box experiment. So without looking at the AC Advisor, I did all my recommendations first, and then I took it and compared to Microsoft. And it does recommend new series where we move from new versions, where we move from version 3 to version 5, but not always. So there's some hit and miss when doing these recommendations and calculations. And the AC Advisor is actually based on 30 days of data points, which is the same data range that we have. So we have the same fundament to do this conclusion on.
Okay.
Yeah, that was actually everything I just said. So can I get a big screen? Just short.
You want to go to the...
Yeah, just really short about the burst machine. So here we have the CPU usage, and we can see when we have a spike where it goes above, like I scaled it down from 4 to 2 CPUs. So you see if I utilize 200% of my 4 or 2 CPUs, then I actually get, then I lose some credits. And then when it has some low utilization, I notice a bit overperforms here, then I accumulate the credits for my next burst. And that's how the burst thermology works, that you can like have these intensive workloads at a short period of time.
But as we said before, things doesn't get more easy with cloud. So now you also have to basically, you have to, in advance, you have to make the calculation, is it likely that I can earn these credits and use them through the bursts? That was what we showed before. Basically, yeah, it seems reasonable.
Yeah, it does.
That you can do that. But as you go along, obviously Microsoft will also tell you, do you have a plus or minus on your credit account? So this is also something that you need to monitor. And if the consumption pattern changes,
then you have to FinOps and change your compute again.
Yeah, because obviously this setup, if you pay what you pay here, it can basically spike at any day, any time, and you will still be able to keep that within the model. It could even have a very long spike for a day or 2 days. You will still be within what you're paying for. But you're obviously paying for too much capacity compared to what you're using. If you scale it down to what Morten is suggesting here, to half the capacity, to 2 CPUs, and also half the RAM, basically you have to rely that the consumption pattern does not change radically.
Yeah, and then bring us back to reserved instance, because if you then have your application and think, okay, I know the pattern now, I bind it at reserved instance, then you're stuck with the machine for that period that you bind yourself for.
Great. So, okay, so what's going on here, Morten?
Yeah, it's like clearly stated, candidate for decommission. So here we have a machine like with a very low CPU utilization, and the memory as well is also dormant, so just have some memory in, just have some data in the memory, and it doesn't really do anything. So I have this machine that's completely unutilized, that you actually just get decommissioned and shut down.
Being the devil's advocate, I would just say, okay, but there are some dots here.
Yeah.
I mean, it does do something, Morten.
Yeah, machine is never dormant. It might be that Microsoft advisor asks for some logs. Can you do a logging? It might be a small health check that the Azure advisor or the Azure platform does. It's really up to the application what it does, because you can also, as the devil advocate, you can also see that like the distance between the dots is quite evenly distributed.
Yeah.
So it might just be some, how can you tell it, like processes behind doing nothing.
But you could also say that even if it does something sensible, you could move those applications probably to another server doing other things as well.
Yeah.
So because it's
consolidate application to a single server.
Exactly. So basically, it's so underutilized that it's almost not utilized. That's really what we're saying, and these are quite easy to identify.
Yeah.
Those kind of servers.
But again, it's back to the FinOps. If you don't do the FinOps, you wouldn't find this server because, well, you can hope that Microsoft Advisor points this server out.
Okay, so I think this is where we go through the cartoon.
Yes.
Right, the different steps.
Yeah, we're gonna take pages from page to the actions that has been done during this challenge.
I will just be the guy pressing the button, and you will tell us what's going on here.
Yes. The first is that we have the virtual machine spend at index 100. If we take all these actions where we say new series, it can be moving to a newer version. It can be rightsizing, that the memory and the CPU and memory ratio fits the metric pattern, or we can make a use of a burst machine. We can find potential saving of 18%.
In this example.
In this example with these servers. And we haven't done virtual machine skill sets optimization, but they are also in part of these numbers. And then, well, often you have a lot of development servers, but why should you keep development servers running during nighttime and weekends? So you can get additional 4.4% by stopping servers that doesn't, like development and pre-prod and test servers that not being utilized. Then the IT department might say, well, we don't want to turn server off during the weekends and nights. Well, then you have the cost of have these servers running off hours. So that is back to like the IT department or the economics of it. Are you willing to pay for having these cloud servers that you can turn off and turn on, giving office hours?
But in this case, this is an anonymized version of real data. But in this case, what you say is that just by turning off the development and test servers during the weekends and night, we'll get 4.4%.
Yes.
Some of you out there will have applications, big applications that have no users during the weekend, for example, but they're still available, they're still running. And here's a basic consideration. Do you want them to do that? Does SAP have to run during the night, for example? Does the different applications, do they have to be available? If the answer is yes, you'll make them available. If the answer is, well, not necessarily, there's the option of closing down the servers during the night, during the weekend, and basically starting them up in the morning, and also giving business units the option to basically request that the application is available on a specific night because we know that we are going to use it. Did you use a script to collect all data for your VM investigation?
I can answer that question. Every metric data is actually in the Azure. So every tenant has these VM utilization metric points. So yeah, given the size of the servers, the server count, it was about 200 VMs. So yes, I definitely used a script to get all the data out. And then the hardest part was actually the processing. Given the amount of data points you get, we got data point every minute for a whole month. That's 40,000 multiplied by 200. Then you have the amount of data points we have to manipulate and process, analyze on. So yeah, we used a script.
Used a script and used Power BI to
R.
R
is a statistical program.
Yeah. So
we used a script to retrieve all these metrics.
For those of you who wants to get even more into the details, I mean, please give us a call or a mail. We'll be happy to go out and do some more in-depth explanations of what is going on here. And as Morten says, it does require, first of all, collecting the data, and then building some basic tools to analyze on the data. We have some of those, and we'll be happy to discuss with you bilaterally on how you can utilize the learnings that we have made during this. So obviously you can automate a big part of this. This is also what we are working on right now. Is actually making more tools to do this.
Yeah, more resources, more application. There's a whole lot of list of resources you also might be interested in, like getting a deeper insight in.
Yeah. So basically, reach out if you want shortcuts to this. We'll be more than happy to share. But let's move on. So we changed the series. We stopped the machines during weekends.
Off hours.
Yeah. So now we are down 23%, but that's not all.
Yeah. Then we have shutdown, and that was the case number 4. Machines with low CPU utilization and memory utilization. By shutting down these dormant machines is 9% of saving. And then you get the question, well, how do you know this application isn't used by some department out there? Well, the easiest way is to figure that out is to shut it down and hear who screams first. But that's 9% savings.
It's like you're going into the hospital,
and
into the hospital
machine.
room. Yeah. Then you plug all the machines and see if someone starts moaning. Any idea on the estimate of FTE hours needed to run FinOps, maybe per archetype? Well, it's a new field. We did some advisory on some specific clients, and I think we ended up in the area of 2 to 3 FTEs for FinOps in a large scale setup.
Yeah, because the issue is that you have one that has to identify all the machines, and then he and she has to go around and knock on doors and like talk with the owner of the application, like we're gonna scale it down because we got these savings. So there's a lot of work, overhead work.
So that you should expect to end in that case, and they will more than pay for their own salary in the savings that they'll find. I think you should take like we usually say about vendor management and other areas. You should take the parking guard approach to this. I mean, hire a parking guard, see if that parking guard basically hand out fines that pays for more than his or her salary, and if they do, try and hire another one until you get to the point where they don't really pay for themselves. Then you can scale back a little. I mean, you should expect this to be some FTEs per year if the load is big. The alternative is, of course, to outsource the FinOps. I mean, ask someone else to do it, either on a T&M, time and material basis, or to ask them to provide a fixed price service. This is a pretty immature market right now, but many vendors do provide some kind of FinOps services. We expect more to do that. And this is also, of course, what we provide to some of our clients is the services of this kind. But we're also very, very eager to basically share the approaches as we talked about and as we are talking about today. So reach out. Okay, so that brought us down 32%.
Yeah, so this is actually still above the Asia advisor. So now we get back to the reserved instance. But there are actually two kind of methods that...
Yeah, we need to explain what is a reserved instance for those of our viewers that doesn't know.
Yeah, so we're going to take the left part, the right part first, which is reserved instance. So here you upfront pay for a reserved instance. So what is a reserved instance? It is a machine with a fixed CPU and a fixed memory, and then you either buy a reserved instance for 1 year or for 3 years. And then we have this blue line, it's a fixed price over time. You know what you pay for, but you have also reserved this instance. So you cannot shut it down and get savings. You cannot stop it and get any savings. You have paid for what you got. And then you can see the pay as you go, which is the gray line, that if you just use pay as you go, of course it's going to be more expense, but then you have the flexibility to change series, to change versions, to shut it down if you find out the application is underutilized. So the reserved instance, you commit as a virtual machine, just like your classic on-premise contract. You buy 100 machines, they have this fixed size. If you do too many changes, you need to renegotiate your contract. So reserved instance kind of is an on-premise contract.
Yeah, it's a locked capacity.
Definitely.
Amount. Yeah.
Yes.
You can use more, but you can't use less. At least you have to pay for what you have agreed.
Yeah, if you don't use it, then well, you have paid the money. Then you need to utilize the machine for something else.
Yeah, exactly.
Alternatively, there is saving plans. It's quite new from Microsoft, saving plans. So instead that you buy a reserved instance, you can buy saving plans. So you say, I know that my peak utilization during the office hours. So you buy capacity in these hours of intensive utilization, but it doesn't cover all services. It's 5 selected services, so you can only use it on virtual machines, on app service, and on SQL databases. So it's a very narrow area where you can like commit some compute capacity. So you can see at the line, if you don't then use all your capacity, then the money is not wasted, but it's go unused. And if when you go above the saving plans, you pay as you go. It gives a lot more flexibility because you're not reserved your instance, so you can change version, you can change series, and you can shut down servers, but you just need to make sure that the amount of compute you use is still at the level of your savings plans. So it gives more flexibility, but it doesn't give as big savings as the reserved instance does. So either you gain some discount and flexibility, or you get high discount and low flexibility. That is the topics.
So now we add reserved instances to the equation here.
Yeah. So one question that's probably going to come up, so I'm going to answer it already. Have we used reserved instance of machine that we stop or shut down? No. We take only reserved instance and the box called new series. So after we have changed all the series, we then apply the reserved instance gains. And by reserving 1 year, we found about 7% of savings. If we then reserved instance for 3 years, it's the 7 plus the 2.8, so it's almost 10% saving per year doing reserved instance. But then you have committed all the machines here for reserved instance. Every machine is reserved now, even maybe some development servers that's not shut down.
Okay, but we've made sure that they are right-sized.
They're right-sized before we reserve.
Before we reserve them, because that's of course the most stupid thing you can do. That is to have an underutilized server that you then reserve for 3 years.
Yeah.
I hope you can see that the sequence here is extremely important. That we start by optimizing before we utilize this more financial tool of reserved instances.
Yes. And the Asia advisor also have these recommendations, of course, with some new series, and might you consider shut it down? And then, of course, you also have the reserved instance.
So what happened here from the 42 to the 41%?
Well, that's the saving plan. So instead, like you get a lower discount but bigger flexibility on the savings plan. So here you get like a smaller discount. You go for, instead of from 7 to 9% of saving, go from 5 to 8% of saving, but have the flexibility of the servers.
So if you were to advise this client, would you say go for the 42% because that's bigger than 41, or would you advise to go for the 41% because it's a very marginal difference and you get a higher flexibility?
I would definitely go with start with like a 1 year saving plan, so you don't commit too many money capex, because that might be some application that you shut down early and all that. So it has to, some application might be well for 1 year and some might be for 3 years, but that is the insider knowledge of the client, how mature our application, and are we going to shut it down early, or is it something that we need to have all the time? So it's not a if else, it's just like it's more fluent.
Yeah. So basically what we're saying is that you need to basically know your load, you need to right size, and you need to get the knowledge that you get from monitoring this over time before you start committing for example, for a 3-year period.
Definitely. That is more of the same. It's a detailed slide of the reserved instance. So we can see the break-even is about 14 months if you reserved for 3 years. And if you make a 1-year reserved instance, the break-even of pay-as-you-go is 8 months. But this doesn't take into account that you might stop a development machine during a weekend and off hours. Then you quickly will, then the break-even will shift to the right if you stop it.
So basically what we're saying is, if you have a machine, it's running constantly at a pretty high utilization.
It's right-sized.
It's right-sized, and we know the application. We have a pretty good outlook on how this will be basically constant over time. Well, then the curve will look like this.
Yeah.
But as soon as something will happen,
it might be that the amount of users increase or decreases.
Yeah, I guess especially if it decreases, then you would actually see that the pay-as-you-go will basically break.
Yeah.
And it could even go down, and you could meet the line again.
Yeah, but also the other way around, if the users increase and need additional capacity, then you have this reserved instance that you all of a sudden is unutilized because you need to move the application to a different server.
Yeah. So basically, okay. So if you have the, I'm not acting here. So if you have a reserved instance of a VM, and you need to upgrade it to a larger VM.
Yeah.
Then you basically need to pay for that.
A new machine.
Then you need to pay for it.
Because it is a reserved instance in the naming.
So the flexibility can be worth a lot of money actually.
Yeah.
Yes.
And that brings us back to saving plans as mentioned earlier. This is more of the same with saving plans, just carved out in great detail.
Great. Okay, we promised to talk about storage.
Yeah.
And just to say that those of you new to our webcast, we do have a subscription service called Quarterly Analytics, and we publish a lot of research on quarterly analytics. We actually do have a number of articles there on storage, on-prem storage, and something on cloud storage as well. But what we're going to present today is actually a little new. It's something that we haven't dived into before. So take us through.
Yeah, this is a focus on 2 storage accounts. Given storage has a lot of metrics, the complexity is grown exponential. So rather than making a lot of calculations of what could be, we found 2 storage accounts. We found the dark blue, which is a hot type, and we found a lighter blue, which is a cool storage account. What is the difference between a hot account and a cool? The hot one is used for regular access, read and write data, while the cool one is used for irregular usage data that you need to access fast. So if you have some backup that you know that you need to access within 15 hours, then you will have it on cool. So it's kind of like cool data that's not being used often. So, but what about the price metrics? Hot has a bigger per gigabyte price. The cool is a lower per gigabyte price. But the transaction of reading a cool is immensely more expensive than a hot, given that the cool is used for backing up storage. So when you create your storage account and you set the flag wrongly, you're gonna see what the result is in a bit. Not yet. Not yet. So I found 2 storage accounts. This is a client data. So the amount of consumed gigabyte is almost equal. The amount of ingress gigabyte, ingress is writing data to Asia. It's often free to write it. But then reading out the data in the hot, the cool is a lot greater than the hot, but it doesn't mix up numbers that much. And the transaction counts is a lot higher for the cool for the hot. It should be the opposite, that you have more data read from the hot than the cool, and you should have more transactions in the hot than the cool, given the name for mythology, hot and cool. So when you create a storage account, one where you have assigned hot and one you assign cool, what happens if you don't utilize them correctly? And now you may go to the next slide.
So basically, before we do it, so basically what you're saying here is that in this specific case, the flag or the selection of hot versus cool, it does not really reflect how it should have been done. Yeah. It's not.
So we can see here that there's a price difference. This is actually client expense that we can see that is different in 88% of cost. So given that the client used their cool storage as a hot storage, made it a very expensive storage account. And by just moving to the cool, well, as you saw before, there was a bit more transactions on the cool, there was a bit more reading on the cool, but the difference might not be 88%, but it might be 70%, which is still a huge saving, given it's cheaper to read from a hot than a cool.
So why is this relevant? Well, if you look at your storage consumption, what most of you will experience is that you will be looking into a massive increase in storage use. from all kinds of applications, ranging from analytics over IoT, machine learning. A lot of intermediate data will be calculated and stored for a while, used or not used. And you will have to select whether to use hot or cool storage. And it's not as self-evident, like as this case shows, what is the right thing to choose. So you might more instinctively say, okay, this is probably not data that we're going to use that much, so we will put it in cool. But as we showed here, well, there might be applications reading this data. You might have users that actually uses the data while you weren't aware of it. And if that is the case, then cool is not just as expensive as hot, it's actually much more expensive.
But we also need to remember that every time you create something, you do it in like what you think is best at the given time. And patterns, like how people utilize platform, might changes. And that brings us back to FinOps, that as the business changes, as how you utilize resources changes, you need to monitor if that you created at some point still reflects the utilization of it. So it might be when the client created this cool storage, they did it from the right assumptions, but then the reality changed and now it's no more fits for the cool type storage.
And the reason why CFOs hate cloud is this, is that in the old days you had an agreement with IBM, Kyndryl, or in an IT even, or DXC or whoever, and you had an outsourcing contract, and you had a fixed price every month until a certain point where you did something and your vendor would come to you and say, hey, we need to change this, you're actually utilizing more, and now you're actually starting utilizing more than we planned. And that dialogue will be a controlled dialogue where you actually have a pretty good picture of your cost. That's not the case anymore. You change your consumption pattern and your cost will change instantly. And you can get to these situations where you will actually pay more for your cool storage than you would have paid if you've selected it as hot. Just as an example. And all the other examples we've showed you before is what can make costs spiral completely out of control. And a lot of our clients are actually experiencing that suddenly they see a 20-30% increase in cloud spend. And the CFO obviously asks, okay, and what about the rest of the year? And without a good FinOps, you're not really able to answer that question. So you need to make these quite detailed analysis in order to control your costs.
This is actually an on-premise case, but it does really well reflect how the setup is a problem in the cloud, because how you utilize the CPU, how you utilize your storage in public cloud and on-premise doesn't really change. So this is a peer sample of how often is data accessed. So we have amount of VMs out of the x-axis, and then on y-axis we have IOPS per gigabyte. So IOPS is like a term for how often is the data accessed. So we have a big group of data that's often utilized, often accessed. That would we advise as saying like that is hot, it's often used. And then we have this slope at the long end. That is probably cool. It might be accessed, but not as frequently. And then you have this long tail that we would say is being archived. And that's bringing us next to the next slide. So if we looked at the consumption of hot and cool at the client, we could see that mostly of the consumed gigabyte wasn't hot. A small percentage wasn't cool, and they didn't have any archive. So I did a small back of the convolute calculation based on how much data they read and how much they read, and said that, well, most of your data can you actually move to hot, and then you have a big chunk of, you can move a big chunk to cool, and then most of the data, which is often what we see at clients, is not utilized that much. So the client would have better off archiving a lot of data. And why should they archive data? Well, that is because the consumption gigabyte is much lower than cool. So just having this dormant data stored as archive is a better business case, but then you have to be aware of retrieving the data is even more expensive than cool, and it takes up to 15 hours to retrieve the data. So if you have some critical systems, you wouldn't put them in archive, you would put them in cool.
Good. So yet another complication. SQL databases. And as you might remember, when we looked at the decomposition in this particular example, we had quite a substantial amount. This was actually the biggest one.
It was top one, and the virtual machine was top two.
Yeah. So, and in many cases, this will be for many of you, this will be the case that if you have SQL databases running, it will be a substantial part of your spend, and therefore also should be a focus of your optimization.
Yeah. Just a quick note here. We have not taken serverless databases into consideration, given how they function. So they're only like spinning up and active when they're actually consumed, and afterwards, when there's no consumption, then pause and you don't get invoiced for unused serverless databases. So thereby, we're only looking at a SQL instance databases consumption pattern. And I don't have any nice dotted graphs here, but it's just the same as the virtual machines. We're going to assign new series based on the utilization of the CPU and memory.
So it would have been the same kind of graphs.
It would have been the same kind of graph.
Where either you would see a lot of dots also in the upper half of the graph, or there will be almost no dots in the upper half of the graph, and therefore you would be downscaling to perhaps half the capacity for some of the SQL instances.
Exactly. So we do exactly the same approach as the virtual machines here. And we skip stop. Why do we skip stop actually? That is because that SQL databases is a plan. You cannot stop plans in Asia. So if you have a SQL manage database, the keyword is manage, then it works like a virtual machine, and then you can stop it. But SQL plans you cannot stop. So we don't stop any databases here, we shut them down. So
what's the difference between stopping and shutting down?
Shutting down is decommission, that you stop, you remove the data.
Okay.
You cannot start it tomorrow. You close it down.
Okay.
So decommission.
I get rid of it.
Yeah, out of the door. So we found some unutilized databases that you can shut down. That gives 10% of savings.
That's quite a lot. So.
And then we go back to the reserved instance here. Given there is a smaller gain in reserved instances because you cannot reserve serverless instance databases. So most of you might know that, like, if you go into the Asia price calculator, you can see reserved instance is often a guaranteeing about 30% discount. A free year is a 60% discount. You're not going to find these numbers here, given that there's also serverless consumption inside these patterns, and there's also data consumption. So that's just like if you're trying to find these numbers, you're not going to find them because it's a mix of a lot of resources, not only if you do reserved instance.
Great.
And yet, so you can see there's no saving plans because SQL database is not part of saving plans. So
we are running a little out of time. Can we? Do you think we can make it?
Definitely. We're almost done.
We're almost done.
Yeah.
Good.
We're just quickly going to go through this. App services is already highly utilized. It's fitted for the cloud because it has the scalability. So if your application is fitted for cloud and you can put it in an app service, the amount of saving is small given the flexibility and scalability in app services. So we found very little here.
Okay, so that was not.
Yeah, and a quick slide here. A newer version is not always cheaper.
It's not always cheaper, but it could hold more capacity. More
functionality.
Performance.
More functionality.
More functionality.
Yeah, because this is not a IaaS service, it's a SaaS service, so you don't know the underlying infrastructure.
Okay.
Yes?
So, what you're saying here is that what we are looking is...
That was only the tip of the iceberg. We only looked at virtual machines, app services, and SQL databases. But what about Kubernetes, Service Bus, Managed Disk, Redis Cache Public? The list go on. But of course, you will always choose those services that has the highest expense. And that brings us back to the first slide with the expense, where you can see that this client has the top 5 was virtual machines and SQL database. Of course, are these resources we would look into.
So, but what you're saying is, if any of our clients have, say,
a different combination,
a different more Azure AKS or whatever, there are metrics that you can basically measure on in order to optimize.
Yeah.
So your utilization metrics will change, but the optimization exercise remains basically the same, finding the right resource to your load.
Yeah.
And that's where all the money is hidden, and is making sure that you have the right resources for your specific load and load pattern, and make sure that you understand that this changes over time. So if you have done that correctly at the beginning of the year, you might find that 3 or 4 months down the road, where you put more applications or more functionality into your application, that is not right anymore, that you need to basically optimize it again. Yeah, there are optimization levels for almost all the resources we're looking at. For some of them, it's more obvious, and for some of them, it will have a huge impact, like the VMs and the SQL instances. But it's basically the same game for all of them. So we started out by the challenge. Can we beat the advisor? And the advisor is Microsoft's own tool that will give you suggestions to optimization. And I guess we will not do any motive interpretation here by saying that they deliberately make this suboptimal. We'll just say that it doesn't catch all the optimization opportunities. It could also be, I mean, if we have to basically be nice to Microsoft, I think we would have to say they will probably be quite cautious in advising optimizations that could harm the overall performance.
Yeah.
So if you have a utilization patterns with a few spikes, they might not advise you to put it down.
Yeah, but that's also part of the FinOps, is to do this analytics of the application. So you need to get these candidates. What candidates are, what machines are candidates for changing series or VM CPUs? So this is the actually advisor cost. Microsoft Advisor has numerous towers. It has security, it has network protocols. But here we're only looking at the cost advisor. So we can see it has like, if you do saving plans, you can save 25 or 28%, and then it has some other savings potential. There is on-demand reserved instance of machines. There's rightsizing or shutting down underutilized virtual machines. There's 3% savings per year. So this is Microsoft Advisor. If we go to the next slide, we can see that 2/3 of Microsoft Advisor falls in the category of reserving instance, like moving, that is a CapEx upfront binding. So it sees that advisors recommends a lot of CapEx to bring your savings down.
It is, I guess, not a surprise that the financial optimization that they will provide and advise on is one that goes well in hand with the interest, of course, of Microsoft, and things that actually have an impact on their stock price and whatnot. That is utilizing reserved instances and thereby committing revenue to Microsoft.
Yeah, exactly.
So it's not a surprise that is what they will advise on. And then they have the rightsizing, which actually here in this case gives you quite a pretty small gain here. Shut down underutilized virtual machines on 3%, and 2% on the shutdown of underutilized virtual machine scale sets. So it's not that much you get from their right-sizing advice.
No, so of course you can see the candidates for right-sizing or shutting down in the Azure Advisor, but given the amount of new series we assign to a machine, we would say that we have found more candidates that a FinOps team would go back in the business and point out, like, do we need to make any changes?
So this is summing up where we started by saying, yes, you will get some of the way with the Azure Advisor, but you will have to commit a lot of money up front, and you will do it in exchange for flexibility.
Yeah, and just one keynote again. If you use the Azure price calculator and see these 30% in discount for 1 year and 60% on average for a 3-year reserved, you cannot find these prices here because the virtual machine has more expense in them than just a reserved instance, and the same going for the SQL. There is some more, so it's not just a peak and queue.
So basically what we're saying is, take a look at the Azure Advisor, but also do the math yourself or have someone help you to do it, because there will be higher flexibility and even more savings by actually doing this in a more detailed manner. This is basically what our approach here has demonstrated. Okay, I think we are. This is basically just what we've shown you before. This is a lot of the overall approach to FinOps and to the continuous cost optimization. These are some of the things that we have touched upon during the presentation here today. We are very, very willing to take discussions with you, as I said before, on a bilateral basis. We are working intensively on building tools and services around this, but we are also willing to, more than willing to share the insights with you on where we are and where we usually find the benefits and the savings in FinOps. So with this, and with no more questions in the chat, I'll just say thank you for good participation.
Yeah, thank you.
And hope to see you soon. And this was the last webcast from our side before the summer holiday. So a very good summer to all of you, and hope to see you soon. Hope to see you after the summer holiday, where we already, I don't know if we've put them the new webcast. They're not on the website yet, but you will be notified when we publish them on the web. We have I think a very interesting series of webcasts planned for the after the summer holiday. So looking forward to see you. Make sure you take care out there. Don't get sunburned, and have a good summer.